Today we are going to talk about modeling. Modeling, no. We're going to talk about trig modeling. Modeling in math means to take a math concept and put it into a setting, which is word problems, which you're all going, I can hear it through the computer. Word problems. I hate word problems. But when are you going to use math in life? Not just being given an equation to solve it, but trying to solve a situation. So trig is actually extremely applicable in many ways. One of our superintendents before Mr. Tolsma actually worked in the military, and he said he was a pilot, and he said that he never learned trig in school. It never made sense to him, didn't see any purpose for it. And then once he was flying, he needed to use trig to figure out like missile trajectories, which seems like super important to be accurate, right? And so then he went and learned trig, and he started to realize how important it was. There's a lot of applications for it. So today we're going to talk about some of those applications. So we're going to be working in right triangles still. We're going to define a few parts of this right triangle in words that you might see in problems. So the first thing is we're going to call this angle here. We've just been calling it theta or sometimes alpha or beta. We're going to define this as being our angle of elevation. Elevation. There we go. Angle of elevation. Elevation like an elevator. So it's like instead of looking straight at the ground, whoop, okay, how far do you have to look up? That's your angle of elevation. Okay. Now, what are some other words that we could label the sides of the triangle with that could be important things in real life? Well, let's start with that vertical. What might we be measuring there? A lot of times we're going to be talking about a height, or another word for height that we might use is altitude. Okay, so a lot of times we're going to be measuring a height or an altitude of something if we're talking about that vertical. What about the horizontal? A lot of times there we're going to be talking about maybe how far away something is. So we might see the word how far away. And so then we're thinking like somebody's standing here at this angle and something else is happening over at that vertical, and how far is it? Another one along that same line would be a distance. We might be measuring a distance there. And another one, and this one can be tricky for people, is this is actually if we took a shadow measurement. A lot of students will incorrectly label a shadow onto the hypotenuse of the triangle, but our shadows exist on the ground. And if I told you to go measure your shadow on a sunny day, you would measure it on the ground. You wouldn't be trying to measure in the air to figure out your shadow. So shadows would be on the bottom of the triangle there. On the hypotenuse, we actually don't use the hypotenuse as much in real life situations. It's kind of rare that we actually care about how long that hypotenuse is. But here's a few things. One would be a kite string. So we've had some really windy days here lately, and we've gone out and flown some kites and actually broke one day because it was too windy. But the kite string would be the hypotenuse there, because kites are going to fly like this. They don't fly right over your head, right? The kite flies out like that. Another thing that could be on that hypotenuse would be like a support wire. So like a telephone pole or something, a lot of times they have support wires connected to them to help on those really windy days, right? So that could be a hypotenuse measurement. And a third one you might see is an inclined plane. And that's kind of the idea of a ramp. So when you're doing a building project, inclined planes are something that's really important to builders and contractors because of ADA regulations. So the American Disabilities Act regulations have strict rules about having access to a building for disability, so for those in wheelchairs. And then there are very strict rules about how steep that ramp can be. And so that inclined plane could be a very important thing to a builder, that ramp there. So those are some words that we might see in word problems. So let's do a couple. Now I'm just going to say the word problems, partly because I'm lazy. I don't want to like write out the whole word problem, and that would be really boring for you too because it'd take a long time for me to write them out. So I'm just going to kind of say the situation and draw the picture as I say the situation. So in our first situation, let's do, let's go fly a kite. Okay, so now you're all singing. Let's go fly a kite. Okay. So here's my kite up here, right? Okay, so there's my kite. And let's say that I measured our angle of elevation to be 25 degrees. Okay, that's the angle of elevation, 25 degrees in that corner there. All right, and let's say that I know that my kite is flying 30 feet above the ground there. Okay, I can just tell because it's like next to a building and I know how tall the building is, and so I know it's 30 feet. And what I want to know is how much kite string was required to do that. Okay, how much kite string? So that's on the hypotenuse there. All right, so here's our setup. Now we want to solve it, and now this becomes exactly the same as what you did in the last lesson, solving for a side or solving for an angle. We're going to set up our trig function. So we got to label this triangle. If I focus on the 25, then 30 is my opposite, and x is my hypotenuse. And so I want to think back. Most of you said you were going to use SOHCAHTOA. There were a few who said Oscar had a heap of apples was going to be helpful because the spelling is a little rough for the word SOHCAHTOA. So as we think about SOHCAHTOA or Oscar had a heap of apples, if I'm talking about an opposite and a hypotenuse, that tells me that I am working with, in this problem, a sine function. So sine of 25 is opposite over hypotenuse. Remember, every equation, trig, angle equals side over side. Every time. Trig, angle equals side over side. You make a little chant. Trig, angle, side over side. Trig, angle equals side over side. Trig, angle equals side over side. Over and over. It'll sink in. Okay, so now we want to solve it. So to solve it, I'm going to multiply both sides by x. That cancels the fraction, but it does not get the x alone. So now I'm going to divide by sine of 25, and I'm going to type into my calculator 30 divided by sine of 25. And so let's see, I got 30 divided by sine of 25, and that gives me 70.986. Okay, I believe on Khan Academy, most of the questions, so 70.986, most of the questions when it asks you for length, asks you to go to the hundredth, which is 2 decimal places. So on this one, we would want to enter our answer as 0.99, I think, is how most of them want side. But just pay attention to those rounding instructions. When does it say 10th? When does it say 100th? Then make sure that you do the thing it asks for. Okay, let's see. Okay, so now I'm going to go fly a hot air balloon. I've never done that before. I don't know if you have. Sounds fun. So we got a hot air balloon. Okay, art skills, right? This hot air balloon is 1 kilometer above ground. And I know that the launch point was 1.5 kilometers away from where I am. So what is my angle of elevation? Okay, so angle of elevation there in the corner. So now I have labeled in my triangle. So now I am ready to choose my trig function. So in this one, label my size. I'm going to choose x, and I have an opposite labeled, and I have an adjacent labeled. Don't care about the hypotenuse in this one, and in a lot of them you're not going to care about the hypotenuse as much in a lot of word problems, but sometimes you will, like a few of those words I gave you there. So in this one, opposite and adjacent, so we like to SOHCAHTOA, opposite and adjacent, that is tangent. So trig function, angle equals side opposite over side adjacent. All right, and then now to peel that tangent off of the x, just like we did in the last lesson, we're going to take an inverse tangent of both sides of this. And so that gives me then that x is equal to the inverse tangent of 1 over 1.5. Type that in my calculator. Inverse tangent of 1 over 1.5. And I get 33.6900, which I believe on Khan Academy, when it asks for angles, it asks for a tenth. So we're going to say 33.7 degrees. And I realized on the last answer, I kind of did a little bit of a no-no in that I didn't label my answer. So feet, right? You always want to label our answers. So feet on that one. Okay, let's take a look at another example. I'm going to go ahead and erase these, but I'm going to keep that original drawing there. I don't know why. We'll have our vocab there. Okay, and keep SOHCAHTOA. All right, so in this one, we're going to be a builder. We're going to look at a house. And we got a measurement of 40 here. And the length along the edge of the roof is 25. Or we want it to be 25. And we want to know what angle would that be for the pitch of the roof. Okay, what angle for the pitch of the roof, or what angle of elevation there. Okay, so now trig has to be done in right triangles if we're going to do SOHCAHTOA. SOHCAHTOA is strictly a right triangle thing because only a right triangle has a hypotenuse. So if I want a right triangle, I'm going to need to drop a little line down there. Okay, now I have a right triangle. But the bottom of the right triangle is not 40. The whole length is 40. So the bottom of the right triangle is 20. Okay, now we're ready to set up. So I've got my angle I'm going to choose. 20 is adjacent. 25 is hypotenuse. So adjacent hypotenuse, that's the ka, so that's cosine. Trig, angle, side adjacent over side hypotenuse. And to solve this, we're going to, oops, I meant to do that in red. We're going to inverse cosine both sides of this. So inverse cosine cancels cosine, like taking off your socks. And inverse cosine of 20 over 25. And I grab my calculator. Right. Inverse cosine, that's the second cosine. 20 over 25. And I get 36.9 if I'm going to go to the 10th. So 36.9 degrees. That would be the pitch of our roof. All right, one more. All right, now we're building an amusement park attraction. We're going to build one of those swing rides where it lifts you off the ground, then it swings you around. My daughter loves these. They have them at like Navy Pier in Chicago and stuff like that too. All right, so here's some things that we know about this swing ride that we're going to build. We know that we want like the chains to be 4 meters. And we know that when they're swinging, we want the swings to be 3 meters off the ground. That's about 10-ish feet. It's like the higher bouncy diving board at a pool or in the Olympics. Okay, and we know that when it's swinging, we're going to get out to an angle of 25 degrees there. What we want to know is how tall do we need to build this thing for this to work out this way. Okay, so what we want to know is how tall. So our answer that we're going for here is this length there. Okay, well, I need a right triangle. So I gotta try to find a right triangle in this picture, and the best right triangle that I see is this right triangle right here. There's a right triangle. That's not exactly the thing that we're trying to solve for, but we're gonna go ahead and solve for that anyway. And I'm gonna call this part then y. So y is not our answer. That's not how tall, but it's going to help us find our answer. So we're going to find that y measurement there because it's like a height. It's just not the height that we want, but it is still a height. All right, so then if 25 is our focus angle, then y is the adjacent. It's right next to it. And 4 is the hypotenuse. And I told you guys, you're not going to use hypotenuse that much, and then we've used hypotenuse in like every question. So I don't know, I guess don't listen to me. I think I just like overcompensated because I said you're not going to use it that much. And so then I tried to think of examples that would use it. All right, so AH, adjacent and hypotenuse, is going to be another cosine one. So cosine of 25, cosine angle, equals side adjacent over side hypotenuse. Okay, so now I want to solve this. I'm going to multiply both sides by 4, and then I can type into my calculator 4 cosine 25, and I get 3.63. 3.63 is y, but y is not my answer. X is my answer. So if y is 3.63 and this bottom part is 3, because that was our goal, was to be 3 meters off the ground, 3.63 plus that 3 meters gives 6.63 meters is our x. That's how tall we would need to build our attraction. So that's not too bad. That makes sense. That's a reasonable height, especially attractions. Sometimes they are super tall, right? Okay, so I know word problems can be tricky, so do your best, try hard, ask me questions, okay? So if you get stuck, take screenshots, email them to me. We can Google Meet, and I can walk you through them as well. So let me know how I can help you, and I'll see you again soon. Have a great weekend.